Hi everyone, this is Mrs. Slauson, one of the Algebra 2 teachers here at Eagle Crest High School, and I will be going over 3.4 with you, function operations. And in this section, we are going to discuss how a radical, so we've been working with square roots and cube roots, can be rewritten as an exponent. Specifically, an exponent that is a fraction. And fractions in the math world are known as rational numbers. So we're going to be calling these rational exponents. And how does that compare to what we're used to seeing, which is known as an integer exponent? And integers are just those positive, negative whole numbers that don't have decimals or fractions. So like -3 and +3. So the way to start this out is just to get you comfortable with exponents. So we're going to start out with 3 to these various powers. So we're going to start out with, I'm writing this down, 3 to the negative first power, 3 to the 0 power, 3 to the first power, 3 to the second, and 3 to the third. And just a reminder, you can always pause and catch up if I'm going too fast. So let's start with some of the ones that you would know. So probably one that you're really comfortable with is 3 to the second power. So 3 to the second power, 3 times 3 is worth 9. And then with that, 3 to the third power, 3 times 3 times 3, that is worth 27. And then 3 to the first power is 3. And so then I usually ask, well, what about 3 to the 0 power? And I usually get 0 as an answer. But in Algebra 1, when you learned about linear versus exponential equations, in an exponential equation, you looked at, well, how do you go from 3 to 9 to 27? And the idea of that is we would have been multiplying by 3. And so to go backwards this way, if you can see the blue, hold on, from 27 to 9 to 3 to this one, we would divide by 3. So if I take this 3 that you're seeing right here and divide it by 3, then as it turns out, 3 to the 0 power is worth 1. And if I keep dividing by 3 this way, then 3 to the negative first power is 1 divided by 3, or 1/3. So one misconception, besides something being to a 0 power is 0, is what is something to a negative power. And negative exponents do not make negative numbers. The rule is they move it, they create a fraction. And so if it starts in a numerator position, then it moves to a denominator. So with this in mind, let's take a look at some exponents that still have 3 as a base, but this time they're going to have a rational exponent, or an exponent that's a fraction. So let's start out with 3 to the 1/2 power. 3 to the 1/2 power is going to fit in right in here because as an exponent of 1/2, 1/2 is in between 0 and 1. So I might not know what 3 to the 1/2 power is worth, but I do know it will be somewhere in between 1 and 3. Or I could take a higher exponent, like 3 to the 5/2 power. And 5/2 as a fraction is 2.5 as a decimal. And so 2.5 would fit in right here. So 3 to the 5/2 power, because 5/2 is 2.5, 2.5 falls in between 2 and 3. I know that 3 to the 5/2 power, I might not know what it's worth, but I do know it's going to be worth something between 9 and 27. So you can get an idea of your answer, but since the numbers grow so fast, that's still kind of tough. So let's take another quick look at this. So between which integer exponents would the following expressions with rational exponents fall between? So let's start with 9 to the 1/5. So 9 to the 1/5, 1/5, if you look at it as a decimal, is just 0.20. If that helps, you can think of it as money, like 20 cents. And that would fall in between 9 to the 0 and 9 to the first. 0.20 falls in between 0 and 1 as far as exponents go. So that means 9 to the 1/5, although I don't know what it's worth, 9 to the 0 power is worth 1, and 9 to the first power is 9. So 9 to the 1/5 power will just be somewhere in between this one, oops, that is not what I meant to do, this one, and this 9. So as far as 13/8 go, if you don't know what 13/8 is, you could always divide it, get your calculator out and divide 13 by 8. And if you do, you're going to see that that decimal right there is worth about 1.625. So where would 1.265 fall in between? 10 to the first and 10 to the second. And if 10 to the first is worth 10 and 10 to the second is worth 100, that means 10 to the 3/8 is somewhere in between 10 and 100. But that's a big range, so it's not really ideal to go about it that way. So what we can do is take these rational exponents that we probably don't know what they're worth and write them as a radical. So what I want you to first do is just look at this a to the mn. That's our rational exponent form. And then here it is written as a radical. There's one option, and then the next column over, that's just the other option of how to write it. All right? So take a look, study those letters where they go, and then we'll do a little bit of practice. All right, so first I know I'm gonna need a check mark. And the first thing I'm gonna be asking you is, what's that little number? That little number there is known as the index. Let's make a little note up here. That little number up here is called the index. So according to 64 to the 2/3, that little 3 is gonna be my index. Now, the number A that's inside the check mark, that is known as the radicand, like that. And so that's going to be the 64. And so as you see, I can kind of start to check these numbers off. So I still need the 2. And the 2 is going to be the exponent that you're seeing outside of it. And in this version, you wrap your radical in parentheses and put the exponent on the outside. In the other version, you just keep that 64 on the inside. So let's keep practicing this. So let's go to the bottom one, 100 to the 3/2. So here's my check mark. My index, this little number, will be the 2. The radicand will be the 100. And the exponent on the outside of the parentheses will be a 3. But otherwise, you could put that 3 inside there instead. So the next one might seem a little overwhelming, and just remember, this negative exponent says it will not make a negative number. It's just going to take our final answer and it would put it as a fraction. So starting with, excuse me, the check mark. My little index number is a 4. The radicand is a 16. My exponent will be a -5. Or I could write it like this and just put the -5 inside. Now, what's probably the better method to use? That would be this first column, because without a calculator, we want to be able to work with smaller numbers. The third column, I should say, where it says radical form as well, you would have to really be good with big numbers and cube rooting them or fourth rooting them or square rooting them. So I'm actually really not going to even introduce this option. I just want you to see that these are interchangeable. So let's go for our solution. Let's start with this cubed root of 64 and then it's squared. So what I had asked my class is, do you know what 64 to the 2/3 power is? Because I don't. So what I'll do is now look at it as a radical, and I'll start by taking the cubed root of 64, which is 4, and then I'm going to apply this exponent, 4 squared, and I get 16. So as it turns out, 64 to the 2/3 power is worth 16. So let's go to the bottom one, the one in red. So first I'm going to do the square root of 100, which is 10. And then I'm going to take that 10 to the 3rd power. So 10 times 10 times 10, and that's 1,000. A trick on tens to a power is whatever that exponent is how many zeros you should have in your final answer. And then the final one, the one with that negative exponent. So what's the 4th root of 16? It's okay if you don't know that. It is 2. And now I'll take 2 to the -5th power. So what I'm going to do right now is just take 2 to the 5th power. So I'm going to multiply 2 5 times, and that's 32. And the negative says just move it into a denominator, which then when you need a numerator, you would put as a 1. So that's how you can figure out some rational exponents, is you can think of them and do the radical, the root number first, and then use the exponent. So there are a couple of big ones, more important ones to remember, and they all happen to be like 1/2, 1/3, 1/4, 1/5. And just remember that at a to the 1/2, it will actually be probably easier if you rewrote this to just know that it's a square root. This 2 is typically invisible, and this 1 is typically invisible. So a 1/2 power is a square root. A 1/3 power is then known as a cubed root. And then anything, not that these are as important, but a 4th root is just a 1/4 power, and a 5th root is just a 1/5 power. But again, if I had to pick the two that are the most important to remember for this chapter, it would be these two. All right, so let's try doing some of these. And before we do, I want you to go to the bottom of the page, and there is a little typo in here, we realized. I left out in this row here one of our perfect squares, so we'll catch it in just a little bit. But going through, the square root of 0 is 0, 1 is 1, 4 is 2, 9 is 3, 4, 5, and then this is where I messed up. I forgot 36, so I'm going to put 36 on there, and the square root of that is 6. And then the square root of 49 is 7, and then I can just work my way up. So if you don't know all your square roots, perfect square roots I should say, here is 0 through 15. And then your cube roots. The cube root of 0 is 0, the cube root of 1 is 1, 8 is 2. You should know those from graphing. 27 gets 3, and then the numbers just work up, and there are definitely way more, but this is pretty good for us. And then this part is just a reminder that rational numbers are just fractions, or if they're decimals, they're really nice simple decimals, decimals that are short or decimals that have a pattern. So let's take a look and try some of these. All right, so first, the first four, we're just going to practice rewriting them. So since these are all rational exponents, I know I will need a check mark or a radical for all of them. And I'm going to go for my index first, then the radicand, just a reminder of the vocab, and then the whoops, one second, and then the exponent. And this is the format I will be writing them in. So on number 1, my index is 3, the radicand is 10, the exponent is 2. On number 2, the index is 3, the radicand is a, the exponent is 1. And then you can try the next two. So I'll be quiet as I write them. All right, the next set, you are given the radical, so now you're going to write the rational exponents. So I'm actually going to start with 7 first. This is going to become b, and I'm going to put this in parentheses for the sake of the calculator. It's always good to put that base in parentheses, b to the 5/4. The next one seems to be missing its exponent, so what's that invisible exponent? It's a 1, so this could be 2 to the 1/6. And then on 5, that little index is missing, so there's an invisible 2 there. And this one can be written as 10 to the 3/2. And then you try 8. And it should be m to the 4/3. Again, wrapping that base in parentheses is always a very good idea. So let's try some of these without a calculator first, and you will probably want to use this table down here of square roots and cube roots. So how can you do these without a calculator? Well, first I'll do the cube root of 125, which I could look down here, and that's 5. And then if you take 5 and square it, you get 25. The 4th root of 81, not on there, but maybe you know that the 4th root of 81 is 3, and then 3 to the 3rd power, 3 times 3 times 3 is 27. The next one, what's the cube root of 27? That one you can answer with your table. That is 3. And then we happen to have, again, 3 to the 3rd power. 3 times 3 times 3 is 27. Now, on the next one, we're missing the invisible 2, and it's written differently. So what you could do is find 9 to the 3rd power, but 9 times 9 times 9 is not a number I know off the top of my head, and then take that number and square root it. Instead, what I'm going to do is look at it in its other format and take the square root of 9 first to get 3, and then 3 cubed, there's another 3 cubed, 27. Now, as far as the next set goes, we want to use a calculator. So take a moment, find your graphing calculator, and I'm going to get mine. So I'm going to pause the video real quick. All right, here we go. So this calculator, I believe, has an older operating system on it. So I think this is actually a really good example of why I do not want to keep any of these in a radical format, because these are such a pain to type in. But if you do want to keep these the way they are written in there, you need to, and I will get that to appear in just a moment, access the math button. So the math button is over on the left underneath the green alpha button, and I'm pressing that, and we will be using option 5. So I've just pressed 5. Well, let me clear that out. So math, option 5. So if you notice what mine keeps doing, and I believe it did it on the other operating system, it keeps saying A and S. So this is the older operating system, and this is why I do not like this. What I'm going to have to do first is go ahead and just let the calculator know that I'm about to have an index of 3. So I will be typing in the 3 first, then I'm going to hit that math button, choose the 5th option, and what the calculator is going to do is going to take that 3 and envision that it's in place of that little x. So if you have an older or a newer operating system, that 3 can actually go where that x is, but right now the calculator knows that that x is the 3 that's in front of it. And then I'll put in parentheses 8, close my parentheses, whoops, I didn't get the 8, and now my calculator knows that 8 is what's being cube rooted, and then I'm going to take that to the 4th power. So actually I'm going to back up. This is not even the best way to do this. So first I'm going to start, no, we can do it this way. So I'll do 3 math, choose the 5th option. I'll take the cubed root of 8, get that number first. Whoops, what did I do here? I didn't hit the 3 first. Sorry about this. 3 math, 5th option. Now it sees it as the cubed root, put 8 in. I'm going to hit enter, so it gives me 2. And then what I'm going to have to do is take my 2 and hit the exponent key, which is the button above the division, and take that to the 4th power, and I will get 16. So this is really complicated. You can see how many times that took me to get this right. So instead, what would be easier is to write it as that rational exponent. I'm going to wrap this in parentheses and show you how to type it in that way. So I'm going to clear out my screen, and I'm just going to put in parentheses 625, hit my exponent key, the number above the division button, and now because this is the older operating system, I will need to let my calculator know that 2/4 is the entire rational exponent. So I'm going to wrap 2/4. You could also simplify that. Wrap that in parentheses, although it missed the 2. And now hit enter, and it's going to give me 25. Or if I go to some of the other ones, so let's take a look at this one. It's 8 to the 3/4 power. Again, wrap it in parentheses. I go back to the calculator. So I'm going to hit 8, the exponent key, parentheses, so it knows that. Whoops, sorry, I want to put the 8 in parentheses though. 8 parentheses, exponent, and now to let my calculator know that 3/4 is the entire exponent, I'm going to do 3 divided by 4. And this time I get a very long decimal, so just go 2 or 3 numbers behind the decimal. Let's see what that was. 7, 6 if you round. And then for the last one, 20 to the 2/3, and maybe you try this one and see how it goes, okay? So for this last one, you should have gotten, if I just round to the nearest hundredths, 7.37. Okay, so sometimes you're going to get nice numbers, and those you could probably do without the calculator, but there are going to be a lot of times that you aren't, so we want to keep that in mind.